Part 9 gives us the equation of a curve, y equals x cubed, but it's got a p in it. We don't know the full equation. What we do know is that it's got a stationary point at x equals 4. As soon as you read something about stationary points, that means we're going to need to differentiate, because we know that at the stationary points the gradient is 0. So if we go ahead and start differentiating it, don't worry about the fact that there's a p there. That is a real number, it's a constant term. We just don't know what it is yet. So when we bring this 2 down here, we're just going to write 2px. The 2 will disappear when we differentiate, the 2 will go to 0. So we know that at the stationary point, where the gradient is equal to 0, it tells us that the x-coordinate So we know that when the x-coordinate is 4, the gradient is 0. So if we substitute 4 into this, we're going to get 3 times 4 squared plus 2 times p times 4, and we know we're going to get 0. So if we simplify this, that's 16 times 3, so that's 48, plus 8p equals 0. So 8p is negative 48, making p negative 6. It says to also determine whether the stationary point is a maximum or a minimum. So we know now that that dy by dx is actually 3x squared minus 2 times 6, so minus 12x. In order to determine whether it's a maximum or a minimum, we're going to differentiate again. So if we do d2y by dx squared, we get 6x minus 12, and when x is 4 at that stationary point value, d2y by dx squared is going to be 24 take away 12, which is positive 12. Got a positive number there, and when we have a positive second derivative, that means we have a minimum point.